And we are live, I believe. New machine, figure out what's happening. Okay, I think I've figured out this. No, I haven't. Alright, let's Is OBS working? Looks like it's doing what I want it to. I don't know. We'll see. Yeah, Akash, how's it going? Okay, bet. Perfect. So my setup's a little bit different, mostly because I'm back at school now. So yeah, we'll see how this goes. We will have to say goodbye to the nice Arch setup for a little bit because I enjoy having a PC. But yeah, it should be a good time. In terms of what I'll be doing today, it'll just be leetcode, and then I'll be continuing with the kaleidoscope tutorial as I have for a while. It actually just occurred to me the stream description is wrong. Let me fix that real quick. And I can't spell. 1 second. Yeah, unlucky. Alright, should be fixed. So yeah. Let's just hit the leetcode. Yesterday's daily was not fun at all. It was this gross 4D dynamic programming problem, but yeah, anyway. The diagonals are back, which is not fun. How's it going, John? I am finally back at school, so the setup is a little bit different, but same old content. Okay, so square matrix. This seems sane enough. And I'm gonna get completely nuked by diagonals again. Because the last time I tried doing diagonals, I spun around in circles for an hour straight, which was kind of funny. It's palm left triangle, sorted in non-increasing order. Oh, interesting. Okay. Have you considered writing a tree-sitter grammar? I've thought about it, but I haven't really had a reason to yet. At least I was thinking about writing an LSP implementation for one of the proprietary languages that one of my classes used, and then I was like, why? So then I didn't do that, but I might try it at some point. How's it going, Ryuma? Oh wait, each diagonal gets its own sort. Okay. Okay, sure. So I'll have to figure out how to detect diagonals here. Not having a tiling window manager really sucks. So let's give this a shot, at least, diagonal-wise. We have... So one diagonal the middle diagonal has 0, 0, it has 1, 1, and then it has 2, 2. And then, oh, the terminal grows like that? That's unlucky. So then above that we have, what is this? This is 0, 1, and then 1, 2. And then above that we have diagonal 0, 2. Where on Windows, because well, the short answer is I wanted to play Valorant on this machine, so can't really do that on Linux, unfortunately. I'm gonna try to install a tiling window manager. I saw, like, there's this Komarebi thing. This seemed pretty workable, at least. It'll do what I want. Wrote a tree stater grammar a while back to get syntax highlighting for HTMX attributes, and it wasn't too difficult. Fair enough. I might try to rewrite the one for Tmux, actually, because that one seemed pretty annoying. Let's just make a new tab for this. Yuck. Because, like, there's some, like, really gross, yeah. Like, the highlighting is not consistent on this for some reason. So I might give that an attempt, at least, at some point. Yeah, Windows West term is not holding up for me. Camera blurry, yeah. It's kind of just doomed. Yeah, okay, so the diagonals, I guess this makes sense. We can just assign each thing with a 0 in a diagonal, and then go from there. And then it's a square matrix, so this is, I guess that doesn't really change a thing. Yeah, okay, sure. What do you think about macros in programming languages? I have the perfect repo for this. It's this one. I think this does sufficient speaking. And then yeah, I think that explains enough. I will not elaborate. Okay, so I guess we can iterate across the first row, and then we can iterate column-wise from there. I feel like that should be largely sufficient to solve this. We don't need this anymore. Ugh. Okay. So, okay. Let's make a 2D vector. Yeah, I lean no macros. Although I feel like I say it's a lean / preference. It's not like a hard and fast rule for me. What is happening to my OBS? OBS is tripping. Okay, neat. Bitrate low. Okay, sure, whatever. If enough people complain about stream quality, I guess I will up it, but I will leave it as is for now. Okay, so we have that. I should probably pre-allocate some stuff. Zero dot size. Yeah, this'll do. So then, let's start with n. Yeah, let's start with n, and then we can sort across diagonal. Oh, it's a square matrix. These are all the same. What about async versus CSP/green threads? I haven't looked into the latter too much, but the little bit of async programming I've done has it's been annoying enough to me. There was like this one article I read about like analogizing it to like colored functions, and I read it and I was like, this resonates a lot with me. So what's the iteration length here? I guess while the other one isn't n. Yeah, I guess. Int x equals I, or x equals 0. CSP/green is go in Elixir. Yeah, I haven't touched either, so unlucky. Oh wait, this is wrong. Y equals I, while... So let's just keep incrementing both until y equals n. So then, let's see. Are there any like constraints on... Okay, nice. I thought there was going to be some like cheeky in-place thing they were going to try and get us to do here. Actually, would a priority queue be faster here? So n doesn't exist. I got rid of it. Basically, runtime just schedules threads for you, and you don't need to mark stuff to be non-blocking. Fair enough, actually. That seems, from a usability standpoint, that seems way more sane than a lot of solutions. So let's push back. Grid of x, y. And we can even postfix increment these. Let's get rid of the brackets, which I definitely won't regret soon. Actually, every time I do this, I get bitten by it. I'm gonna keep the braces. Yeah, async store just infects your entire code base with incompatible functions. Yeah, that's exactly it. Let me find the article actually. It was like this one, I think. Is it this? Is this one? Yeah, it was this one. Yeah, he talks about like how languages suck. Yeah. Yeah, I'm not gonna like reinvent the wheel. This is... Oh, that's a lot of comments. But yeah, I like this article a lot. I think that shapes a lot of how I think about async. I guess it makes sense to like... I think it makes sense that like for async stuff, the abstractions are kind of just like useful at an abstraction level. Like, I think it's like fair enough. As in like, at the end of the day, someone has to like write functional code. So if we're writing stuff that actually does things productive, then we may as well have a language that supports that. Let's just sort. Let's see if this works how I remember. Okay, nice. What's the default comparator? Ascending order. Okay. So non-decreasing order. So top right, that means this one's correct. Okay. And then I just wish Rust had a solid CSP runtime. Yeah, fair enough. But I feel like if you're using Rust, you're probably gonna use Tokyo anyway. So like, sure. Is sort really a sane way to do this? I guess we'll see what happens. Actually, is there a better way you could iterate across this? I feel like I'm overcooking. Yeah, I'm overcooking. Let's do a for loop instead. We can get rid of these 3 lines. Let's do that. Let's replace this with J, and then this is J minus I. Save a couple of lines for no discernible reason. And then, yeah. And let's do this again, I guess. There has to be a better way to do this. I could just reuse grid and save this allocation. Let's do a little bit of cringe stuff here. So let's do grid of J minus I of J equals cur of J minus I. So that's one leg, and then we do for int I equals 1, I is less than 1, I plus plus. And then now we do the other half of the triangle, or the other triangle rather. So I could just steal this and then flip some conditions. When has that ever gone wrong for me? Yeah. So let's take this. And then we have to reverse this. Stood greater. Is that how it works? No, I need to, there we go. So then let's take this. J minus I there. And this should be, oh wait, this is different because we start with 0. I think. -1. Let's give this a try. If you read that ANSI book, they're always using weird kinds of for loops. Yeah. Oh, I forget to return. Return grid. Yeah, people are doing crazy things. Oh, it's not ideal. Where am I going wrong here? Okay, let's see. Which of these for loops is it in? Okay, so we got there. Oh, minus I, empty. We got it? No. Oh. Yeah, when has getting rid of the braces prematurely ever bitten me, huh? Okay, we got there once. So this, okay, so that has to be in here. Maybe the -1 is just wrong. Oh yeah, because yeah, it just skips one. That's why. So then this should be good. No. Oh, the diagonal didn't sort correctly. Okay, let's just make this a 0 and then let's make this a 1. Okay. Now let's see how much slower this is than everyone else's solution. Oh, it's not bad actually. Okay, bet. Let's see what the editorial says we want to do. This is what we did. Okay, no priority queue. I can't really complain. Actually, this is literally what I did. Let's see what the actual fast submissions did. Oh, why is there a map? An unordered map. Yeah, here's an example of a of an interesting for loop. We have -n+1. I don't understand the point of this. Surely there has to be some submission explanation. Okay, this is particularly uninteresting. So yeah, I guess that's leetcode done at least. So now we go back to Kaleidoscope, which is where all the fun stuff lives. Where did Kaleidoscope go? I have it open on my other... Yeah. So yesterday, I did nothing because I was on a plane, and then I got completely one-shotted by the plane. But the day before, we did all of this chapter, which was quite nice. And what this did was we added user-defined operators to Kaleidoscope, which was this language that we have. Let's just make a new terminal. Yeah. Yeah, so we stole this test from the tutorial itself, and this runtime library is stuff that I have because I thought it was easier than reusing existing libraries, but so we implemented things like unary not, unary negate, the greater than operator, and just like some general convenience things. And then there's this like print density function, and then we use that to print Mandelbrot. So if we go here, oh, I don't have CMake, 1 second. Whoops. Let's get that installed real quick. Does this build? Wait, that's not a thing. Okay, so then... Yeah, we already have alluvium. What? Wait, where is this? Why is it struggling to find this? Alluvium IR builder. What you mean? Alright, it might be a second because I actually do have to fight with this for a second. Huh. Why is that not being found? Yeah, so it is just that file. So that comes from here. Clangd is installed, so then what's breaking? Also, no undercurl is unlucky, but I'll fix that some other time. Huh. Is anything being imported? Doesn't look like it is. What is Espin? Yeah, it looks like it's just not importing. Or maybe Clangd is not finding it? Let's see. WSL, Fedora, can't find. Oh, wait, do I need this? That might be why. Yeah, it looks like this is what I need. I need to actually install the libraries. Okay, so now it looks like it finds everything. So now if we make alright, well, it's building now, so that's huge. But yeah, while this builds, yeah, it turns out LLVM stores its libraries separately. So, unlucky, I guess. But, yeah, so we have this nice little Mandelbrot test. So then if I run kaleidoscope and then input the Mandelbrot test, it prints it out, which is pretty neat, if I do say so myself. Yeah, we can ignore this std-in mess, but yeah, so that's what we did last time. But the problem is this whole time we have not had variables. We have sort of had variables in the sense that the for loop condition has a variable, and then we've had variables in the sense that like function params are variables. But besides that, we don't have a user-defined variables yet. So that is what we will be implementing this time. What's good, Frothy? Good to see you around. So yeah, let's just get this set up again. Yeah. Yeah, this says pretty much, oh. Yeah, this says pretty much what I just said. So, variables actually are quite annoying to generate code for, just because functional languages kind of, or I guess like functional languages are really easy to generate code for, but variables are a little bit annoying because SSA form is annoying to keep. So I peeked ahead a little bit in this tutorial, and this section kind of roughly explains why. So if you were to draw the control flow graph for this sample program, you would get like a diamond shape, and then you need to insert a fee function to resolve what gets returned. And that's quite annoying because we have to preserve SSA form. Today's topic is finally adding variables to this cursed language. Yeah, spot on. Yeah, so the problem with just like naively inserting variables is that, or at least in theory, it would just be easy because then you can just reassign values, and then from there you can like generate the SSA form. The problem is you just literally can't do that with LLVM. So the answer to that is we just make everything memory, and then we let mem to reg in LLVM handle SSA construction. Yeah, this explains that roughly, because memory doesn't need to be SSA. Okay, so we want to make a stack variable for each mutable object. And I need to read this section because I don't actually know this too well. So all memory accesses are explicit with load store instructions, and it's carefully designed to not have or need an address of operator. Notice how the type of the g/h global variables is i32 pointer star. That's a interesting font. Anyway, even though the variable is defined as i32, so where is this? It's up here. So G defines space for an i32, but its name refers to the address for that space. So stack variables work the same way, except instead of being declared with global variable definitions, they're declared with the alloc. Okay. That seems reasonable enough at a glance. Okay, so yeah, sure. Load, do a thing, store, sure. Yeah. When I go back to actually trying to build my own compiler again, I might do this and just make a mem to reg implementation. I'm pretty lost in today's topic. I guess I need to read it myself after stream. That's fair. I guess like the high level explanation for what we're doing is we can't really just directly define variables because we'd have to worry about constructing SSA. Because variables in an SSA form, which I guess let me back up a second. So SSA is static single assignment. There was like this Wikipedia article in one of the earlier tutorial pages, but the idea is each variable is only assigned once. So you can, and more like, the way that I explained it to myself first was just that whenever you like reassign a variable, instead of reusing an existing variable, you just make a new one. And that's like a rough idea of, I guess, what's happening. I guess I should just pull up the Wikipedia page. This is not the SSA form that I particularly care about right now. Yeah. Just like this example here. So here we assign y to 1, or 1 to y rather. Then we reassign y to 2, and then we assign x to y. I might have gotten the words backwards, but you get what I mean. So if we were to just perform a simple like constant propagation optimization to like y, different identifier for each assignment, yes. And this is useful because if we were to if we were to do this without an SSA form, we would have to figure out which use of y is being used here. And that's really annoying because you have to figure out like which variables are like created and which variables are like, or like which variables are alive and which aren't at any program state point, and like that's kind of annoying. And then if you make like any change, you have to like completely redo all of that analysis. By making each variable single definition, that allows you to sort of preserve that sort of information in a sense. And this unlocks a whole lot of optimizations, or at least it makes them a lot cheaper. So that is like roughly the explanation. Hey MRJ, how's it going? Yeah, I think that's like the short explanation of SSA form. Back to why it's relevant here. When we're creating variables, we'd have to construct SSA while we create the variables. Simply because LLVM literally does not allow you to reassign variables. So the naive way to do it would be to figure out SSA construction while the naive way would be to like construct the SSA form as you're like cogenning it. But that's kind of annoying, so we can just make these all memory values and then use LLVM's mem to reg pass to just turn them into variables. Creating a compiler using LLVM? Yes, I'm specifically following their kaleidoscope tutorial. And we've gone through chapters 1 through 6 already in previous streams, so we're working on chapter 7 right now. Also, one other thing I want to mention is that this sort of memory variable implementation is also what LLVM does for Cling, if I remember correctly. Because I was poking around with this a while back. So we have like, let's do a C program. So let's just do int I equals 0. Well, it's a bit too old. No, the tutorial gets updated. It gets updated, I guess, incrementally, so it works. Look up a book to learn LLVM. Okay, interesting. Yeah, I mean, I guess I could do this. Yeah, I'll give it a look at some point, but I feel like this tutorial is largely sufficient, and I'll just keep working with further projects. By memory value, I mean like a stack variable, I guess. So we compile this with 0. You're wasting your time following that tutorial? Respectfully, I have to disagree. The whole reason I'm following along with this is at least like, okay, so first of all, this is LLVM 20. So factually, saying that it's outdated is wrong. The tutorial, if the tutorial's in that book, then like fair enough, but I mean, I think this works sufficiently, so like, sure. I mean, you're free to have your own opinion, but I'm already like this far through this. I may as well get it finished. I also think it pretty much has everything that I care about in terms of like the compiler front end, and then from there I can mess around with the optimizer and code gen as I see fit. Oh yeah, what I was showing here was that Clang uses stack variables in its code gen as well. So like it doesn't actually make variables here, but if I compile with like O1, I think it creates variables, I think. I guess O1 already optimizes this out, but let's just make main. Let's make I equals 5, and then square with I guess. Okay, well this is not particularly helpful. Let's make this more interesting. Actually, can I just reload the old square function? Yeah, this is a good one to start with. I can't spell for the life of me. Let's just do a max array of I and then I as an example. Oh, these are double pointers. Oh, okay, so we can't actually do this because I can't read. Default. Yeah, there we go. Okay, well it just keeps getting folded out, but you'll just have to take my word for it that it generates variables from the stack variables. So yeah. Anyway. So moving forward here. Yeah, this code's an example. So stack memory is fully general. You can pass the address of the stack slot to functions. You can store in other variables, etc. We could rewrite the example to use allocate to avoid using a fee. Okay, so we allocate that. And then this is the function for reference up here. Also, I might be moving a little bit fast through this because I want to get to writing code, but I'm at least just trying to figure out what's going on here. Yeah, so this is the update in one branch, this is the update in the other branch, and then here there's a read. And this is useful because then we don't have to generate the fee node, and we can just let LLVM handle that for us. LLVM docs, yeah, the docs are a little bit hard to, they're a little bit hard to parse, but luckily the docs are sufficiently indexed into ChatGPT for at least my initial learning. Whereas Arch, it's still on my laptop, but I'm on my PC right now because I like having real compute power. Yeah, we're unfortunately in Windows land for the foreseeable future on stream. Okay, so each mutable variable becomes a stack allocation, each read becomes a load, each update becomes a store to the stack, and then taking the address of the variable just uses the stack address. That's nice. We have apparently introduced a lot of stack traffic for simple operations. That's true. Yeah, memtoreg, our beloved. Okay, so this is after we run memtoreg on it. Okay, yeah. And then it generates the fee for us. Life is good. Okay, we love this. Okay, so it's allocate driven. Only looks for them in the entry block. Only promotes allocates. Who's used our direct loads and stores. I guess that roughly makes sense. And then first class values. Okay. Okay, that roughly makes sense to me. Easy to satisfy for most imperative languages. We'll illustrate below. This seems painful. This doesn't seem like it would be better in any sense. And yeah, I guess, sure, I guess that makes sense. So I guess we get to start copying code by hand and figuring out what it does. So let's see what this looks like in the context of this language. So we add the equals operator, and then we get to define variables. Okay. We get to do iteration. You look tired? Nah, I feel it might just be the lighting or the angle. Or maybe just being back on campus. Lord knows. Okay, so this exists still, sure. Okay, so we've had this before. But now we can do iterative. Okay, nice. So now we need to use the allocate trick for the variables from our function params, and then in the for loop body. I bet it's the Windows? Yeah, it low-key might be. Yeah, jokes aside, I feel like it's probably the lighting. Okay, sure. So we have this name values map, and then it holds memory location. So we change it to map to allocate instead of values. Interesting. But are these values? Because this would be a value, right? Okay, well, I assume there's like a sane reason to do this. I guess we don't need the level of abstraction that value provides, so that makes sense. Okay. Okay, so we make that, and then we need to change it in here. And then let's let this tell us where we need to change things. This is basically the last major feature of the language, yeah, pretty much. Because the rest is just like minor LLVM things, which... so object files, that is like the one thing I actually do want to care about. The one thing that I do actually care about. Debug info, I guess I should probably learn, and then this is neat, I guess. Okay, let's see. Actually, yeah, I guess we could just look through named values. Okay, so I'm gonna help her to create them in the entry block. That makes sense. Let's make that in here as well. Let's keep growing this giant this giant mess of a file. So then that's the static. So then this takes a function and then var name. Okay, I guess that makes sense. At least it's not one file. Yeah. This is arguably worse though, because like now I'm sort of half-assing it almost. Oh, LVM string ref. Okay, interesting. Well then. Yeah, I guess that makes sense. Okay, this is like... Sure. Okay. This funny looking code. So we have a string ref, var name. Whoops. Okay. So let's throw this somewhere in here. Oh, I didn't get rid of that? Okay. So now I have the formatter double bound, actually. I need to fix that real quick. Let me... Also, yes, laptop exists here. I just forgot to push some .file changes. I'll do that real quick. Wait, what changes are here? What? Sorry, give me a second to remember what I did. Oh, okay, sure. Okay, let's just... Oh yeah, I have hard time on. I forgot about that one. All right, well I get to get bunked over the head by that again. That'll be funny. Where was I? Here. Yeah, I need to format that. And then, okay, here we are. Oh wait, we do have undercurl, I think, right? Okay, I guess we don't have undercurl. That sucks. Okay, so how's this implemented? So we make a temporary IR builder. And then we create allocate. Okay, that seems fair enough. So this takes in what does this constructor take? Wait, I already made one of these. I should know this. Also, this is the wrong file, so this is a moot point. Okay, here we are. Have it somewhere up here, right? That's not really helpful. This is the other constructor, right? The one with the basic block? Yeah. One of these two. Presumably this one. Right? No. Hey Karam, what's up? Is it this one? This one's longer. Okay, well, I guess we'll figure it out as we go. So let's just steal this, but by hand. So we take, let's do that. So then we get entry block, and then get entry block, begin. Will be freshman and comp student in September. That's really cool. Yeah, there will be a lot of knowledge to absorb initially, so yeah. Oh, this is, there we go. So builder, create, allocate. And then this takes in the usual. Okay, that makes sense. Wrong window, unlucky. And then this takes in context. Footer, and then var name. Seeing so many things online about you should do this and that, yeah, that's kind of the first year experience. And there's always going to be a lot of people like telling you what you should and you shouldn't do. What is going wrong here? Oh, I put the brackets wrong. Yeah, a lot of people will tell you what you should and you shouldn't do, but honestly, like if you want to just like, if you want to sort of just like stumble through it, I think you'll definitely learn a lot that way as well. The big thing is just like, as long as you have like some semblance of a plan for how you approach things, you can't really go that wrong. And even if there's something where you do something your way and then you're like, damn, I really should have I should have learned X, or like I should have paid more attention in Y class about Z topic. There's still plenty of time to relearn things and sort of brush up on your knowledge. Like in one of my intro classes that covered C++, I kind of breezed through that because I was like worrying about other classes, but given what I'm currently doing now, I kind of wish I paid more attention. But it's never too late to like learn things, even if it's just like relearning the fundamentals. And that's also part of why I've like started streaming things. And I've been like learning more about C++ as time has, I guess, progressed. Okay, so we've gotten this. So, we need to generate a load with variable expr. So this is in here. Okay, it's up here. Okay, then we need to change this to allocate_inst. Okay, well they renamed this variable as well, so I guess I have to. But then we don't return the allocate. We create a load with this. Okay. Oh, I'm in tmux. Whoops. So let's do. Also, it just occurred to me that my mic here is a little bit worse. So, so yeah, I'll try and get a new mic. We'll see what happens, but no guarantees. If the keyboard sounds get annoying, like please let me know, and that might push me towards buying a new mic. So that's A. This is A, and then name from there. What are we missing? Get allocated type. Eh? Am I tripping? What? What changed? Oh, I see. Oh, so the one time there's a small g. Okay. Hi, I'm new in C++, just learning the basics. Can you tell me a documentation or a book where I can learn how to build compilers? So I've been following this tutorial on LLVM, but I received feedback that apparently this is not amazing, and there is another book to follow. It was sent above somewhere. Yeah, this one, apparently. I haven't checked this out yet. It seems at least pretty solid for learning. So that might be worth looking at. There's also like a bunch of other like more theoretically dense books. Like I tried reading through the dragon book, the fabled dragon book, the one that everyone mentions. That one seemed really dense. There's one by like Appel or Apple, I don't know how to pronounce his last name. That one apparently has pretty good feedback. I think that's like a pretty sufficient PAL to at least get started with. If there's anyone that's like more experienced in chat that could give a better answer, I would defer to that. Currently studying maths, just redid pre-calc before union, gonna look into calc 1 and phys 1. Yeah, I think that's a pretty good place to start. At the end of the day, the intro sequence is just the intro sequence. Like, if you have to take it, you have to take it. Yeah. So we stole this. Now we need to update the things that define the variables to set up the LK. So, okay. Presumably it would be here. This isn't a value anymore. Oh yeah, I need to insert the thing here. Create store, and then, wait, what's happening here? Okay, instruction. Oh, I see. Okay. So we create the LK, and then we cogen the stuff that goes into that, and then we create the store. I see. Okay. And then we reload, increment, and restore the okay, gotcha. So that is just like the standard variable access procedure. So we load, we do whatever to it, and then we restore it. Sure. So let's create that here first, the creation of it. So we create entry block. Am I just being gaslit by these like small? Oh yeah, because I made this function. Okay, I have gaslit myself. If anyone was wondering why I'm using like lower camel case instead of upper camel case, it's because I didn't know that the style guide requires upper camel case, so I've kind of just made this decision, and I'm left to deal with the consequences. So this gets the function, and then our name, yeah, that works. And then we cogen it. Where is this originally cogened? here it is. So we keep that, and then we create the store. Yeah, okay, so that's like the first half. So now I need to compute the end condition. Cool hair color, by the way, thanks. Thought about dyeing my hair, but it's just too scary. Yeah, I can't say it wasn't scary when I first dyed mine. The biggest advice I have is just, it's fine to like, so there's like two main big things. The first one is like getting your hair bleached. If you don't have like lighter color hair that can take color easier. And then the second part is like actually coloring the hair. It's pretty safe to just like color it yourself as long as you don't like cover your entire face with like dye somehow. But the bleaching is definitely scary if you don't really know what you're doing. So if you wanted to do some of it yourself, I would suggest like getting it professionally bleached, but then I guess if you wanted to like apply the dye yourself, then like go for that. Oh right, end condition. So I think it's, do we need to deal with this like shadowing thing anymore? Oh, we don't even need the fee anymore. Oh wait, that's really nice actually. Wow, okay. And then we use load and store to access. I guess, yeah, we don't need this anymore. Let's check the code listing. Maybe I should just Control F, but whoops. Okay. Wait, what? Oh, right, because it still has a, we still have to worry about the name aliasing. So we do still need that. We still need this segment. Yeah, Windows fatigue is already getting to me. This this is unfortunate. Where did I go? Oh. Okay, so we have that. Want to go here. Presumably we fix that soon. So then okay. This goes at the end condition. Down here. So we keep that, and then we do the thing. So then var gets a load, next var gets an add, and then we just create a store. If you're still here watching the stream, make sure you sub to my channel and give this spot a like. It really helps me out with the algorithm, and it helps get this content promoted to more people as well. So we get the type, we have allocate, and that's the address, presumably. And then var name dot c str. Right, other way around. Yeah. And then we create the add. The F is float, in case anyone was confused. So we take curvar, we add step val. Yeah. And then this goes into next var. And then we store this in. Oh, whoops. Do I need that anymore? Or yes, I do need that. Oh, wait, we already have... Okay. I did not see that. So let's just paste over that and call it a day. We also need to... We need to make allocates for local variables. Yeah, I guess this doesn't walk through all the other changes that need to be made. Okay, sure. So then let's fix this up. Oh, we don't need to make the fee anymore. And this one we set to allocate, I think. Is that what's happening? Let's see, did I get it correct? I can't find, there it is. Yes, okay. That makes sense. And then this is in a completely different place, okay. Wait, no, this is in the same place. Yeah, because we don't need var anymore. And then this one's in a completely different place. Okay. So we have, I think that's pretty much everything in here. I guess we'll find out very brutally if this is in fact not everything in here. It's so far, I appreciate it. Okay, so now function time. Function time. This goes... Oh, we also need to add passes. Okay. Yeah, here it is. So it goes in here. Does it go here? No, this is prototype. I'm in the wrong place. Yeah, it'd be here. So this is still fine. New args looks fine at a glance. Is it? Yeah. The stuff roughly seems fine. I might have to check if this needs to be changed. And then, so we start here. Oh wait, it actually does this for me. That's nice. And then we need to expand this out. So we create the allocate, we store the initial value, but in the current block instead of the entry block. And then we add arguments to the symbol table. Okay. Sure. So we take that, and then that equals create entry block. Okay, this takes in F. Did I call F? Yeah. And then this takes in arg get name. Get name, get name. And then we create the store, crate. This takes in arg and then allocate. Yeah, we're storing arg in allocate, and then we need to change not that one out. We need to change arg out for allocate. And then that should be good. Oh, we need to add memtrudge. Yeah. That one seems pretty important for writing performant code. So let's throw that in here. Yeah, I'll need to fix this up. And then memtrudge is just called promote pass. Oh yeah, sure, okay, fair enough. And then what's this header called that it requires? Memtrudge, okay. So this is transforms utils memtrudge. Okay, nice. Oh, this is yucky. Let's make this consistent with the rest of this. And then I think that's it. Yeah. Okay. So let's rebuild this. Let's see what happens. Ah. As internal linkage was not defined. What if I just... Wait. I don't understand enough about static. I'll worry about that later. Oh, I see. Okay. Yeah, fair enough. I forgot static does static things. So this should be good. Yeah, nothing's yelling at... Oh, something's yelling at me. Did I forget to remove it here? Yeah. So then we should be good to go. Surely. Oh yeah, I should run it by feeding it code. Let's give it, not source, tests. Let's give it fib. And then, aha. Okay, it does things. Oh, I see, we ran mem to reg, yeah. Okay, well, that doesn't tell me anything. So let's get rid of those. Let's go to, let's go here. Not, is it here? No. It's in this file. And then let's comment this out. And then let's see what code it generates. Because memtreg was turning all the stuff we did into variables, which is what we want it to do, but not really helpful in terms of actually looking at the code itself that we've generated. So then, did I just give it like a function that doesn't have variables? No, it has a variable. It definitely has variables. Where are the loads? There's no allocate. Where am I going wrong? I guess it's... Oh, right, this is a function pass, I think, is the problem. Is that the problem? No, it shouldn't be. Wait. Oh, wait. I remember. I call opt somewhere, I think. Yeah, there we go. Okay. So new plan. Let's go back here, and then let's comment this out down here. And then let's try running it again. And then hopefully it should not optimize, which is a very funny sentence. Okay, there we go, okay. Yeah. Yeah, I guess this stuff here is explaining the example from before. But here when we Yeah, so when we start, we allocate these two. And then we do the stores. That's fair enough. And then I see the loads, adds, and stores. So yeah, that's pretty neat. Yeah, let's get rid of these two again now. And then yeah, next is the new assignment operator, and that seems pretty straightforward at least. And then yeah, we need to add the rest of the stuff, but yeah, I think I'm actually gonna call this stream a little bit early. I still want to get some setup stuff worked out before I stream for my usual duration. So yeah, let me just add this to Git. Yep. So yeah, that's about it for today's stream. Thank you all for tuning in, especially if you stayed through this whole thing. Make sure you like and sub. It really helps me out with the algorithm, and it helps get my content out to more people. If you haven't already, you should follow me on GitHub, and you should connect with me on LinkedIn. And yeah, I'll have tomorrow's stream scheduled. It should be around the same time as today. So yeah, thank you all. Take care.